Integral Ad Science, Team SamurAI, or SamurAI.
Do you guys hear me in the back? I feel like I'm way too tall for the podium. Can I get a thumbs up if you hear me? Sweet. My name is Alexander Navratil. I'm from Integral Ad Science. We came all the way from New York City to solve the Google Carrefour Hackathon challenge. Now, the other teams have told you all about the challenge, so I won't belabor the point. And we'll get right into our solution, which really came in two parts. The first part was a machine learning algorithm that identifies hotspots, postcodes where we can safely reduce the catalog expenditures. And the other part of our solution was a software tool, a custom-built software tool for performing what-if analysis. And I'll tell you more about both of those in the next couple slides. Now, I promised you that we were going to make recommendations per postcode. And if you think about it, really, in each postcode, there's only two things we can recommend. We can recommend you leave the spend the same, or we can recommend, on the other hand, that you change it. So far, it doesn't sound like rocket science, but under the hood, there's actually some fairly sophisticated technology. And in this case, we had pretty good luck, and it worked very well. Now, a big part of this hackathon is that each team submits a machine learning model, and the judges assign a score. And as other teams mentioned, the score that was used here is the root mean squared error. That's the RMSE. And this score is like golf. Lower is better. And as you see on the chart there, we included a chart for the engineers in the audience. You can see we ended up with a RMSE around just below 4, which was the lowest out of any team in the division. We like to think it's pretty low. Now, of course, every team had the same training data from Google and Carrefour and the other event sponsors. And as you notice, we used an XGBoost model, which was the same model used by almost every other team. So you might ask, where's the secret sauce? Why does yours work better? And the answer is, of course, the automated feature engineering. So this is a procedure which we used at the very beginning of the modeling process. We took the data which was provided as part of the hackathon and ran it through the automated feature engineering. And that automated feature engineering transforms it into a form which is more useful for the XGBoost model. So a lot of our success is really attributed to that single step of the whole process. Now, machine learning is all well and good, but for business purposes, of course, we need some insights. And like every team, the format of our insights is going to be a list of postcodes. Some postcodes in which you can reduce the spend without damaging sales, some postcodes in which you can leave the spend just as it is because it's already at the optimal level. And of course, there are even a few postcodes where the spend should go in the other direction. Now, I don't speak French. I'm not even going to try to say these. Maybe the sophisticated Europeans in the audience can handle it. But of course, we have a postcode by postcode breakdown. So within each of these regions, there are a number of postcodes, perhaps as many as a dozen or more. And so we emit a recommendation for each of those single postcodes within the regions. And this result was really driven by the twinned matching algorithm. We match regions with an algorithm that was developed by our resident in-house math PhD, Dr. John Kittrell. Thank you, John. And this algorithm is really the heart and soul of the project.
Yeah, but everyone needs to be aside to watch the other presentations.
So on the chart here, you see two time series, one in green, the other in purple.
As you can see what other people are doing, like now the guy just changed his speech
and these regions are
because
similar
some people
in
have
very
very similar what he has. So I suggest you go.
Demographics, similar sizes, and they're similar in every respect except one. The only way they differ is the level of catalog spending. So you can see here that on the vertical axis we have the sales in those regions, and they're very similar at most times, and yet the level of catalog spending is drastically different. So this is a good example of a pair of regions where we could probably reduce the catalog spend without hurting sales. So this was a good idea and it worked well. We decided to wrap an interface around it. And more than anything, we see this as a tool for mitigating risk. Because of course, changing the spend on a catalog is a big business decision. It makes people worried. So the more we can mitigate the risk, the better. Now you might ask, does this software add value only within a single region of France? Or does it generalize to other areas? And we think the answer is yes. Of course, Carrefour has operations in many countries, in not only France, but also in Spain and Germany, even in Poland. And it's likely that in many of these markets, the data is in a similar shape. So it's possible that this software could be a drop-in solution in a situation like that. We could take it across geographies to other Carrefour markets and add value. We also think that there are many other industries with a similar shaped problem. So you can imagine there must be many, many companies in the world which have catalog distribution and sales, and they would like to establish a causal relationship between the two. So we think not only could this software add value across geographies, but also across industries. So I've made this thing sound pretty good. But of course, it was only a 24-hour hackathon, so it's far from perfect. And first and foremost among our problems, and among our shortcomings, is that we've really only addressed half of the problem space. So if you give us another week, we think we could build models that would establish a causal relationship between the digital ad spend and the increase in sales. And that's a problem which is near and dear to our heart because we do it all day as our day job at Integral. So with that, I will stop talking. They told me there's no time for questions now, but if you'd like to catch us after the talk, we're happy to address whatever questions you have. Thank you for your time.